So, last class up to drawing arcs in isometric views have been completed. Let us start with dimensioning in isometric views, though dimensioning I have covered earlier for orthographic views. So, horizontal and vertical dimensions, both extension and dimension lines are in isometric planes. Remember, dimensioning should be done in isometric planes x, y and z. You cannot do dimensioning beyond isometric planes, because if you look at here, this is your object and this is my planes x, y and z. Numbers are perpendicular to the dimension lines. How do you know if your isometric drawing is correct? As I said earlier, from isometric drawing you again draw front view, means 3 orthographic views you can redraw it, then you can check whatever the view has been given to you, top view, front view and side view, whether it is matching or not. If not, then there is a problem in isometric drawing. It should yield exactly the same orthographic views from which the isometric drawing was built. So, let us start with some basic constructions, more number of examples that will help. We have finished by means of box method. Offset method I have not shown, offset method also easy. So, isometric axis is, first you draw a line with respect to that 30° x and y you can draw, then z with that perpendicular you can draw it, or you can draw it 120° each. This is 120°, this is 120° and this is your 120°. Once you draw the isometric axes, then let the dimensions corresponding to actual dimensions, then if it is a isometric drawing, then it should be actual dimensions. If it is isometric projections, then it has to be reduced equally by means of 0.82. So, these dimensions from isometric scale you take it and mark it, so that you can finish your isometric box. That means, you are foreshortening in x, y and z directions. So, for example, square in a diamond shape, square becomes rectangle in isometric, circle becomes ellipse as I said earlier. So, how do you draw? In the front view, in the orthographic view, in the front view, if there is a circle, or in the top view there is circle, or maybe in the side view there is a circle, take equal number of points around the circle. What I am doing? I divide it into 4 parts, then again I draw it and mark the points along the circles. Mark different points 1, 2, 3, 4, 5, 6. More number of points you take it, it will be easy to plot your ellipse in accurate way. Then draw your same dimensions, you draw it in isometric scale or isometric view. Then mark these points, respective points, taking the coordinates with respect to, as I said, by means of box method, taking a reference point, take the coordinates, with respect to that you mark your coordinates, then draw the ellipse. So, circle becomes ellipse. Now, similarly, this circle can be drawn ellipse in top, front as well as side view. Approximate ellipse I have covered by means of 4 center methods. You can draw your approximate ellipse, and arcs, up to this we have covered arcs this. Then let us start few many examples by means of offset methods, or you can draw it by means of box methods. Winner stand. If you look at the winner stand, simple winner stand where your number 1 winner, first runners up, second runners up, then winner, they have to stand one by one. This is a simple winner stand, and this is your top view, front view, and this is your side view. Then by means of offset method, draw the base, then take your respective offsets. Offset means, that means you are raising. First you draw first you, if you look at your, first you draw the base, then take the respective dimensions in the up. Instead of constructing box, then do it, you can do it by means of offset methods. Directly you can measure the dimensions with respect to coordinates and take it by means of offsets. Do it, finish it. You can do the coloring, you can do the coloring how it looks. So, this is a simple stand, simple winner stand, like first runners up, second runners up, then champions is simple rule stands. Then you can cross check, then you can cross check with this whether this is correct or not by taking this front views. Where is your front view? We are looking from this side. If you look at the color, this is my front face, look at the color, this is the top face. Obviously, this will be merged because this point and this point, once you are looking from the top, will be merged. So, it will not be there, this color will not be there in the top view. Then go to the side view, then you can check whether is your top view, side view and front view are correct or not. If it is correct, your isometric view is correct. Now, come to the second side block, second example side block. Just many number of examples I am solving. You can try these same examples at your home, practicing by means of box method or by means of offset method, so that very easily you will be familiar to drawing isometric, either isometric drawing or isometric projections. Now, it has been tried by means of box methods. Just put it a color, slide block, this is a side block is coming, you can cross check with your top, side as well as front view. Then kernel, offset method, this is not by means of box method. Remember, in the box method, first in the box method, finish the isometric box, taking the dimension of width, height and depth, finish your box, complete box, finish it, then project it back, then erase it. In case of offset method, draw the top, bottom part, then from with respect to that coordinates direct mark your points with respectively, then finish your drawings. This is by means of offset methods. For your convenient, I have drawn it by giving the colors. I am slightly doing, not going in detail, so that you try. Unless you do not try, then it will be difficult. If you try it, it will be slowly you will practice. So, it will be easy for you. Then throne, it has been drawn by means of your offset methods. This is your example 4. Thick pipe, in the thick pipe what happened? Look at this example, example 5, thick pipe, top view is circles, 2 concentric circles. These 2 concentric circles looks to be in isometric ellipse. So, basically along the circles find it out and take as many as number of points, so that you can redraw or you can draw ellipse very easily. So, it has been marked your points inner as well as outer, first is your outer as well as then inner circles. Then draw these outer circles at the base, because thick pipe is your continuous. This is your top view and this is your front view, it is continuous. If you look at the front view, then there are dotted lines here. So, that means this is your inner circle, this is your outer circle. So, concentric circles, thick pipe. So, then base of this you draw it, mark these points and same points you take it, draw the ellipse, then go to your inner part at the base, take these points, draw it. So, this is your top view, top part is over. Then if you remember here, this top part I have drawn here, then in height on the depth directions I am going back, then again in the, after taking this height or the depth, taking it again draw your ellipse, then draw the ellipse, both these concentric circles, draw the ellipse. Once you have finished at the top and at the bottom, then it will be very easy. Draw the tangents, draw the tangents. First what you are going to do, draw the tangents from here to here, then draw the tangents from here to here. Then once the tangent is over, then you visualize which part you are going to visualize. You see. Now, if you look at here in this way, if I draw it, I can see, because top view I can see it. With looking at the front view this is your dotted lines. I cannot see the inside circle or throughout it is there, it is a dotted line. So, that means you erase it out in the frontal face, only put it this outer circle. So, then it will become, you can finish it your drawing, then this is your final drawing. Before this part is there, top and inner circles, bottom inner and outer circles, or then this outer circles projected back here, then it will become ellipse, top and bottom ellipse. Once you finish, draw the tangents, then look at how it looks, how your isometric drawings looks like. So, that if you are looking from the front face, so that it can coincide your front view. If you are looking from the top face, it is going to coincide what is your top view is given. Donut, now same thing, two circles are there, make it, mark these points, do your ellipse, outer ellipse, then look at your inner ellipse, then go to your depth directions, go to the depth directions, do it again, outer ellipse, do your inner ellipse, do it inner ellipse, then draw the tangent. Look at, this is my drawing, whatever I have drawn. Then how the object should looks like? Then you take the object and look from the front, look from the top, so that match your both the views. Then remaining part, like this part and this part will be it is not supposed to be visible. So, you make way with that, some part is going to be visible in isometric, how it is throughout. Then obviously, once it is throughout, other part like this part is not going to be visible. Example 7, notched block. In the notched block, if you look at here from the front view, there is a notch like this, from the top view again there is there, and side view is there. Looking at this, you can draw it by means of box method or offset method. How it looks by means, it has been drawn by means of offset method. This is your object. Then notched block, example 8, how it looks. These are all examples you can try. I am just going slightly faster, just explaining one by one example. You can try both these methods, as I said, either box method or by means of offset methods. This is all about your isometric examples. After isometric examples, there is a new chapter. Let me start with your oblique projections. Oblique projections, look at this. This is a first introductions, first you understand, then it will be easy. When does an isometric view results on a projection plane? This is a question. When does an isometric view result on a projection plane? Projection plane is your PP. When the object is rotated and tilted with respect to vertical and profile axis respectively, what happen in isometric views? In isometric views, what happen? First you rotate with respect to vertical 45 degree, then rotate along your profile plane 30 degree some minutes, then you are supposed to get your isometric. When the object is rotated and tilted with respect to vertical and profile axis respectively, and the projectors are parallel to each other and perpendicular to picture plane. Remember, projectors are parallel to each other, that means these projectors are parallel to each other and perpendicular to picture plane, perpendicular to a picture plane. An oblique view is formed by parallel projectors that makes an angle other than 90 degree with your picture plane. Look at the difference. An oblique view is formed by parallel projectors. Projectors are definitely parallel to each other, but makes angle not perpendicular to your picture plane, other than your perpendicular to your picture plane. The object is not rotated. First difference you got it, this is the first point you are getting. Not perpendicular to your picture plane, but the projectors are parallel to each other. The object is not rotated or tilted. Remember, like the way isometric it has been rotated and tilted, has a major face parallel to your picture plane, major face parallel to your picture plane. If there is a picture plane, one face is parallel to your picture plane, so that front face of the object is seen in its true shape. In oblique view, front face of the object is always in true shape. Why? Because that face is parallel to your picture plane. The height and width of the object remains at 90 degree to each other. The details of the object along the depth are shown along a depth axis taken at an arbitrary angle, normally 30 degree to 45 degree. Last point, the details of the object along the depth are shown along a depth axis taken at an arbitrary angle, that is 30 degree to 45 degree. That means oblique view in depth directions, for oblique view in depth direction it has been made an angle of 30 degree to 45 degree. However, for front face always parallel to your picture plane, that means your front view is in your true shape. The depth direction may be taken either left or right and up or down. The depth direction may be taken as left, right, up or down. We will go in detail. First one I have drawn, this is your rotated with respect to vertical axis, then tilted with respect to your side plane. This is your isometric view. Oblique, look at here, this is a front face and it is parallel to your picture plane is somewhere else here, parallel to your picture plane. Then what will happen? Look at here, in depth directions it makes an angle of 30 degree to 45 degree, but here first it is isometric, it is rotated with respect to vertical axis 45 degree, then tilted or may be rotated with respect to your side view, then it is coming all the view, you can see it, all the sides, sorry, all the view, not all the view, all the sides you can see it. Oblique view, oblique projections, front face is parallel to your picture plane, that means you are supposed to get, if it is parallel to picture plane, you are supposed to get true shape of the front. In depth directions it has been made an angle 30 degree to 45 degree, either it is up, down, right or left. If I am telling up, this is up, it can be made down with respect to left or with respect to right. If it is there with respect to right, of this side if you are doing with respect to left. True shape, details along depth axis. The oblique method is used principally for objects with circular or curved. Now, next question you can ask, what is the difference between why we are doing orthographic, why we are doing isometric, why we are looking for oblique. Oblique method is used principally for objects with circular or curved features, only one face or on parallel faces, and for objects of this type the oblique is easy to draw and dimensions. Particularly it is for circular and curved features only in one face or parallel to that face, so that oblique can be easily drawn and you can do the dimensions. Oblique projections produce 3D views. First point, process virtually opposite to isometric view. Process virtually opposite to isometric view. Do not look perpendicular through object plane. Do not look your perpendicular through object plane. Object is not rotated. Object remains with a major face parallel to your projection plane. Major face, front, side, depending upon that, parallel to your projection plane. One looks the projection plane with an oblique angle. One looks the projection plane with an oblique angle. Axis of height and width, remember here, axis of height and width remains 90 degree, not in depth. Height and width, if I am taking this object is like this, if I am going in these directions, that means this is my width, as I said, this is your height and this is your depth. So, width and heights remain 90 degree. That means, this is your true shape you are supposed to see, width and height there. Axis of depth can vary in angle of phi, varying from 30 degree to 45 degree. Isometric, this is what your oblique, 35 degree to 60 degree. Step 1, there are different steps, step 1, step 2, step 3, step 4, step 5, step 6 and 7. We will explain. What is your step 1? Drawing an oblique drawing, draw a rectangle overall width and height of the object. Why I am looking at width and height? Width and height, they are particularly front face and they are perpendicular to each other, so that the front view, front face is giving your true shape. That means, this true shape first you draw a rectangle overall width and height. First one, draw rectangle overall width and height. Step 2, extend parallel lines from each corner of the box back at an angle. Each corner of the box, extend your parallel lines at an angle. In the depth direction, what is your angle has been given. Mark the extension lines at a point equal to depth of the object. You are extending, mark the extension, what is your depth direction, depth dimensions. Connect the depth of lines from a box. Connect the depth of the line from a box with this respect to that. Step 1, draw your width and height, then parallel lines from each corner, then mark the depth directions, then connect it. Add any details such as holes, notches onto the front view. That means, this is your true size and true shape in the front view. Anything is there, add it. Extend the details, the depth of the object. Extend the details in depth directions. Then once you extend it, because this is in true shape, once you extend it, complete the sketch by darkening this object. You finish your sketch, darken the object. This is your all the steps how to start with your oblique drawing. Procedures, look at one example. Front view and top view has been given, reference points coordinates has been taken, here is your reference point, next is your draw the reference point, then first step is your draw width and height, this direction is your width, mark the width, this is your height, mark the height, this is your height. Then in depth directions it is 30 degree to 60 degree, mark the 30 degree in the depth directions, take your depth dimensions, finish it out, all you finish. This is your front face, this is your width, this is from here to here dimension, this is your height, this dimension is from here to here height. Then with respect to that, here it is given, with respect to that this arc will be always given, inner and outer arc will always be given. So, then find it out the center, then draw the arc, outer, inner. Then once you finish it, because this is your true shape, this is your front view, this is your true shape. In depth direction you go in depth directions. What I did, front face has been finished, in the depth directions I have taken, mark the depth, and again parallel to this, with this parallel to this I have taken, mark the dimensions, here mark the dimensions, then join it. I have joined it, then here you mark the dimension, then draw the inner and outer circle, then join it by means of a tangent, then finish your drawing. Is it going to show that all the views? No, some part you have to erase it. You see, this part I am not going to see in oblique, red mark, this you have to erase it, because this is your inside. So, I have taken it out. Now, how it looks? This is what it looks, your oblique drawing. Oblique drawing example 1, 30 degree to the right and up, 30 degree to the right, if I am sitting here 30 degree to the right and up, remember. This is your top view and front view. Take the reference point coordinates, draw the width and height, 30 degree to the right, 30 degree to the reference to the right and up, means it will be towards up, 30 degree up, finish your depth, mark your center line, draw your circle, this circle is your true shape, this is your true shape, because this is in front view, extend it in depth directions, draw the circle again, finish it, do it width and height, then extend it in depth directions, then I have shown that which part has to be removed, I have marked which part I am not going to see it. This is what I am not going to see it, this is what I am not going to see it, other I am not going to see it. I am going to stop it here. Next class I will extend oblique drawings or more examples. Thank you.